Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 1 to 5 of the next generation Accuplacer Arithmetic practice test questions. Alright, let's take a look at question number 1. It reads, which of the following fractions is equal to 0.06? Let's do a real quick review on how to convert from decimals to fractions to percentage. Okay, so let's recall the following. Let's say you have 0.1. What's the fractional equivalent of 0.1? 0.1 is 1 over 10. And 1 over 10 is the same thing as 10%. Okay, so numbers can be written as decimals, as fractions, or as percent. What if we have 0.01? 0.01 as a fraction is 1 over 100. Now, do you notice a pattern? You have 1 right after the decimal point, so you have 1 over 10. You have 0.01, now you have 1 over 100. So the place value of the 1 tells you what goes in the denominator. Okay? For 0.1, 1 is in the tenths place, so you have 1/10. Over here, 0.01, 1 is in the hundredths place. So that gives us 1 over 100. Okay? In percent format, this is 1%, 1 per 100. Let's take it one more step further. What if we have 0.001? What would this be in fractional form? It would be 1 over 1,000 because 1 is in the thousandths place. Alright? And this is equal to 0.1%. So this is just a little quick review on converting from decimals to fractions to percent. Now let's go over this particular problem. What are the steps involved in converting 0.06 into fractions, since we have fractions as our options? Let's go over the steps, and then we will apply it to this particular problem. Okay, so the steps are to convert decimals to fractions. Okay, so if you want to convert decimals to fractions, first things first, what you will do is you divide the given number by 1. Okay? Preferably 1.0. If you divide it by 1 or 1.0, you have exactly the same thing. There is no difference between 1 and 1.0. Secondly, you move the decimal point. We are talking about the decimal points in the numerator and the denominator, right? Move the decimal points until the numerator is no longer a decimal. Okay, until it's no longer a decimal. In some cases, you have to reduce. In some cases, like this particular problem, you do not have to reduce. Okay, so step 3 is to reduce where applicable. Alright, let's go ahead and apply these steps to this particular problem. So we have, for problem 1, 0.06. Step 1, we're going to write 0.06 divided by 1.0. Now the question is, how many times do we have to move our decimal point, and in what direction, in order for the numerator to no longer be a decimal? The answer is twice. Okay? You move your decimal point 2 places to the right. 1, 2, and we'll have 6. In the numerator, that's no longer a decimal. But whatever you do to the numerator, you have to do exactly the same thing to the denominator. Okay, so you're going to move it 2 places to the right, also 1, 2. Moving the decimal point 2 places to the right is equivalent to multiplying the numerator and the denominator by what? By 100. So that's actually what we're doing. Okay, so we have an open space here. We have to insert a placeholder, namely 0. There has to be a digit between 0 and the decimal point since we created a space here. So our fractional equivalent of 0.06 is 6 over 100. This can be reduced further into 3 over 50, but if you take a look at the options here, we do not have 3 over 50 as an option. Okay, so it is left in its unreduced form. Answer to number 1 is option letter D. Okay, let's take a look at question number 2. It reads, a club has 36 members. If each member donates 12 items for an auction, how many items will there be in the auction? Let's get started by taking a look at the formula that's going to guide our problem solving process. If you would like to gain access to our collection of Accuplacer formulas to help you do well on your exam, you can visit our website at mathgotserved.com under Accuplacer, and you see a collection of formulas there to help you prepare for the exam. Now let's write down the formula. For this particular scenario, the formula that we're going to be using has to do with total amount. Okay, so the total amount is equal to the number per item, or units, number per unit, multiplied by the number of units. Okay, this is a very nice formula to know because you're going to have multiple questions where you have to apply this particular formula. Okay, let's now adapt this formula to this particular problem. Okay, so what's the grand total? What's the total number of items that we're looking at here? We're looking at the total number of items in the auction. Okay, so total amount of items in the auction, that's equivalent to our total amount, is equal to the number of what? Number of items per member. So how many items did each member bring? So this represents our number per unit. So in this case, what's the unit? The unit in this particular problem is equivalent to a member. Okay, so 1 unit is represents 1 member. Okay, so number per unit is number of items per member. We're now going to multiply that by what? Number of units in this particular problem is number of members. Okay, so let's go ahead and substitute what we know. The number of items per member, if you look at the problem, it says each member donates 12 items. So each is another word for per, okay? So number of items per member is 12. And then we're going to multiply that by the number of members. How many members are there in the club? There are a total of 36 members, so we'll multiply that by 36. So the result of this product will tell us the total number of items that there will be in the auction. Okay, so for problems like this on the Accuplacer, calculators will not be allowed. Okay, so if a calculator is allowed, a calculator will pop up on the screen to allow you to carry out the computations. But a lot of the arithmetic problems do not allow the use of calculators. There are problems that allow the use of it, but most of them do not require, or you will not be allowed to use a calculator. So you need to be fresh with your arithmetic skills in order to do well on the test. So let's multiply this. This is two-digit multiplication by a two-digit number. So we have 12 times 36. Okay, so when you're multiplying, of course, you want to align the numbers vertically. Put the bigger, it doesn't really matter since it's just two digits by two digits, so it doesn't really matter the way you order it. But ideally, the number with a higher number of digits will go on the top. Since they're the same, it doesn't matter how you orient the factors. Okay, now let's multiply. 6 times 2 is 12. 2 carry 1 to the tens place. 6 times 1 is 6, plus the 1 that you carried over to the tens place. You add that to the 6, you have 72. Now you're advancing to the tens place. In order to avoid making mistakes, you put a 0 in the units, in the ones place, to tell you you're now putting your products in the starting from the tens place and up. Okay? 3 times 2 is 6. 3 times 1 is 3. Just simply add downwards. Always start adding from the ones place. 2 plus 0 is 2. 7 plus 6 is 13. Carry 1. 432 items total. So these are the total number of items that there will be in the club. Answer for number 2 is letter D. Now let's take a look at question number 3. Question 3 reads, what is the value of 4 over 10 plus 3 over 100? Okay, so now there is something you want to remember when you are adding fractions. Okay, so let's recollect that fact real quick. So one thing you will have to recall concerning adding or subtracting fractions, you want to remember that in order to add to find the sum or subtract to find the difference of fractions, the denominators must be what? The denominators must be the same. Okay, they must be equal to this special value known as the lowest common denominator. Okay, so that's the condition. The denominators have to be the same, and then you can go ahead and add. Okay, so let's take a look at the formula for adding or subtracting fractions of identical denominators. So let's say you have a over c plus b over c. Okay, what do you do in this case? Well, the denominators are the same. It's simply going to be a plus b over c. Notice when you achieve the LCD or identical denominators, you don't add the denominators. You just add the numerators and keep the denominator the same. Okay? Remember, c cannot be 0 or we'll run into problems. Okay, now let's go ahead and apply these instructions to this particular problem. Change this real quick. So c cannot be 0. All right, now we have to add 4 over 10 plus 3 over 100. The denominators are different, so we can't add. Okay, so what we need to do is we need to find the LCD of find the LCD of 10 and 100. So the question is, what is the smallest number that 10 and 100 can go into evenly? Oh, check this out. Since 10 goes into 100 and 100 is bigger than 10, our LCD is automatically going to be 100. Okay? So if you're looking for the LCD of two numbers and one is a factor of the other, the bigger number that the smaller is a factor of is automatically the LCD, because 100 goes into itself and 10 will automatically go into 100. So that's the case here, so we don't have to carry out any long procedure to determine what the LCD is. Okay? Now the goal is to cause the denominators to accomplish a value of, to attain a value of 100. 3 over 100 is already there. So we have to focus our attention on 4 over 10. Now what do you multiply 10 by to get 100? 10 times 10 is 100. So we multiply the denominator by 10 so that it becomes 100. Now is it sufficient to just multiply the denominator of 4 over 10 by 10 and compute the sum? The answer is no. Anytime you multiply the denominator by a value, you have to multiply the numerator by the exact same value, which is equivalent to multiplying this fraction by 1. Okay? So what we're doing is converting 4 over 10 into an equivalent fraction with a denominator of 100, the LCD of these two denominators. Okay? So what does that accomplish? We will now have 40 divided by 100. Let's write that down. 40 over 100 plus 3 over 100. Can we add right now? We can, because the denominators are identical. Okay? So 40 plus 3 is 43, and the denominator stays the same. 43 over 100 is our answer. Option letter A is the answer to question number 3. Now let's take a look at question number 4. It reads, a conference planner has put together 280 binders for attendees and another 31 binders for presenters. How many total binders did the planner put together for attendees and presenters? Now to solve this problem, let's go ahead and write down the formula that's going to guide our problem solving process. We're going to adapt our formula to this particular scenario. Okay, so the total number of binders is equal to the sum of the component binders that form the total. We have two component binders here, attendee binders and presenter binders. Okay, so it's going to be the number of attendee binders plus the number of presenter binders. So that's the formula we're going to use to solve this particular problem. Okay, let's do it. So total number of binders, we're looking at a combination of attendees and presenters, is going to be the number of attendee binders, which is 280, plus the number of presenter binders, which is 31. Okay, so when you're adding numbers, you want to orient it uh, vertically. Okay, paying close attention to the place values so that you do not make any errors when you're combining digits. You don't want to combine um, a number in the tens place from one with a digit in the hundreds place in the other number. Okay, so I'm gonna orient my addends vertically. 280, the one with more digits, put that on top, and 31. Okay, so you see how my ones place line up, my tens place line up, and my hundreds place line up perfectly. Okay, so let's go ahead and add downwards. 0 plus 1 is 1. 8 plus 3 is 11. 1. Don't forget to carry the 1 over. So this 1 add to this 2, you get 311 binders total for attendees and presenters. Answer to number 4 is option letter C. Now let's take a look at question number 5. It reads, a store stocked 150 cans of popcorn for a weekend sale. That weekend, 72 of the cans sold. Question, what percent of the cans of popcorn stocked were sold that weekend? Okay, before we solve this problem, let's go ahead and write down the formula that will guide our problem solving process. Okay, so the formula, we're going to call it the percent of whole formula. Remember, we have our collection of formulas at mathgotserved.com, or you can just look in the description. We'll have a link there to direct you to our website where we have the formulas and other great tools to help you get ready for the Accuplacer Next Generation test. Okay, so the formula is percent of whole is equal to the part divided by whole multiplied by 100. Okay, percent of whole is equal to part divided by whole times 100. Another variation that you see often is percent of whole over 100 is equal to part over whole. They mean exactly the same thing. This is just one variation of that formula. Okay, so now let's adapt this general formula for percent of whole to this particular case that we have. So we have the percent of whole. The whole here is the percent of whole number of popcorn sold. Okay, percent of whole number of popcorn sold is equal to the part of the popcorn that's sold. How much of the popcorn was sold? It states here that 72 sold. So the part is 72. Whole represents the total number of popcorn that the store had in stock for the weekend sale, and that is 150. Okay, so 72 divided by 150 is our part over whole. To render it in percentage format, we'll multiply by 100. Okay, so let's simplify this. We can cross reduce. Now we can divide by 10, which is equivalent to just canceling out these zeros right here. Okay, when you're reducing, you can cancel common factors in the denominator with a common factor in the numerator. When you have a product, you can go diagonally or vertically. Okay, so what else can we reduce? Either vertically downwards or diagonally between the 15 and the 10. 15 ends in a 5, 10 ends in a 0. What number goes into every number that ends with a 0 or a 5? The answer is 5. Okay, so divide 15 by 5, you have 3. And then if you divide 10 by 5, you have 2. Does 3 go into 72? How do you know if 3 goes into a number? All you simply do is you add the digits and ask yourself, does 3 go into the sum of the digits? So 72, just add 7 and 2, that's 9. Does 3 go into 9? Yes. 3 goes into 9 three times, so that tells you that 3 um, goes into 72 evenly. Okay? So what's 72 divided by 3? You could do your long division, or you can just do it directly. Let me do the long division on the side here. So 72, the numerator goes underneath the division bars, divided by 3. 3 goes into 7 twice. 2 times 3, 6. Subtract that. 1, 2, 3 goes into 12 4 times. Okay. So 72 divided by 3 is 24. So let's go ahead and do that. Divide 3 by itself, it's 1. And 3 goes into 72 24 times, as we did with our long division process, to the right. Okay, now what we are going to do is multiply 24 by 2. Okay, so 2 times 4 is 8. 2 times 2 is 4. Our answer is 48%, which represents the percentage of popcorn that was sold that weekend. Our answer to question 5 is option letter C. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Accuplacer exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments concerning what we covered in this presentation, or any Accuplacer math question in general, just place your questions or comments in the comment section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other cool tutorials such as this. More clips can be found on mathgotserved.com, including our formula collection and a nice variety of practice questions. Thanks again for watching, and have a wonderful day. Goodbye.